Hello and welcome to Mission AI's Core Python Programming course. Now, in this video, I'm going to cover Module 4, which is Control Structures, and that basically refers to conditional logic, that is if-else statements, and loops. So we'll cover the while loop and the for loop here. Now, in the previous modules, we looked at an introduction to Python, and we also covered all the basic as well as advanced data types, right? And now in this module, we start putting those data types together and processing them in different ways to actually achieve real world outputs, right? Like if you think about real world programming, it's typically responding to the world in some way, right? It's taking some inputs. Based on that, it's performing certain kinds of tasks and then gives an output accordingly. And in this chapter, in this module, we're going to understand how exactly that happens. So the first thing we look at is conditional logic, right? And as the name suggests, it's a structured way of generating outputs based on conditions or criteria. Now, in I think it was module 2, we looked at conditional operators, right? And that was like greater than, less than, equal to, not equal to, and so on. And these basically formed conditions, right? And in this case, what we're going to do is we're going to take those conditions, and if the condition is true, we're going to do something. And if it's false, we're going to do something else, right? So in a sense, we're bringing this intelligence into our program where it responds to some input and then acts accordingly. I'll give you an example of some conditional logic, right? Like in the case of a hotel, right? Like the doorman would be there, and you could have a simple rule saying, if the hotel guest is female, say welcome, ma'am, else say welcome, sir, right? This is a real world example of conditional logic. Another example is if the student scores more than 90%, give a gold medal. Else, if the student scores between 70 and 90, give a silver medal. Else, give a bronze medal, right? So the first condition was just if and else. The second condition was if, else if, and then else, right? And we're going to look at both such situations in this module. So let's look at using if, elif, and else to implement conditional logic, right? So I'll just take you through this over here. This is the syntax, right? And one of the important concepts we're going to cover here is the concept of indentation in Python, right? So the way you write it is if, and then the condition. The condition can either be like enclosed in curly in curved brackets or not. Like it's completely up to you. I prefer using them personally just because it makes the code much more readable, right? And if you have a simple condition, that's fine. But if you have like a more complex condition, the use of brackets actually helps a lot in terms of understanding the code. So if condition, then you write a colon, right? Now, everything that comes after this, right, it's a block of code. Now, this block of code has got to be indented, which means that if the if statement started at this level, which is here, then I need to give one tab space for the code inside the if block. So, either a tab or four spaces. That's Python's way of understanding what is part of the outer program and what is part of the if block, right? It's this indentation. And once the code block is completed, then you go back to this original level, which is the leftmost part of the editor, and then you type in the next statement, right? In this case, it's else if, which is written as elif. So if has a condition and then colon and then a block of code. Then elif has another condition, a colon and a block of code, and this block of code is also indented. And finally, you have an else, right? Now, obviously, the else is the last thing that comes here in this sequence, and it's what happens if all the previous conditions were false, right? So in terms of order of execution, first Python checks this one, right? If this is true, it executes this and avoids these two. Now, if this is false, it then comes to the elif and checks if this condition is true. Now, if this condition is true, it executes the code over here and then avoids whatever is in else, right? And if this condition is false, then finally it comes to the else block and executes the code that's under else. And again, the code block that's under else is also indented by one tab or four spaces, right? So remember, if condition, then you have a colon, and then you have your indented code block. Elif condition, then you have your colon and indented code block. And finally, you have else with no condition, just a colon, and you have your indented code block. So this is the syntax, right, for writing if, elif, and else conditions. As mentioned, there are some important points here. Either you can do with or without the brackets. Personally, I prefer them. Remember the colon. This is important because that tells Python that what's coming next is the code belonging to the if or the elif block. You can include any number of elif conditions, right? So you start with if and you specify the first condition. After that, you can have any number of elif conditions. Like you can have 25 if you need, right? It's just going to be like there's very few cases where you're going to write 25 conditions, but if you need, you can, right? There's no limit. And the last thing, the last block that you want executed if all the previous conditions were false comes under else, right? And remember, this is a condition, right? So as we saw in the case of our conditional operators in module 2, it should evaluate to either true or false, right? And that's how Python decides what gets executed. The result of your condition should either be true or false. And you can use any combination of functions, operators, expressions, arithmetic, relational, logical operators, everything. You can use the in keyword, you can use different data types, whatever you need. Like you can stuff this part between the brackets with literally anything you want, as long as it evaluates to either true or false. So let's do some exercises now, and I'll show you how to write if, elif, and else conditions in real world programming, right? So now there are four variables with values 1, 2, 6, and 5. So let's create four variables, and these are obviously integers, right? So v1 equal to 1, v2 equal to 2, v3 equal to 6, v4 equal to 5. So I've created my four variables. If the sum of the first and third variables is equal to the sum of the second and fourth variables, print this message. Else, print this message. So in effect, what I'm saying is I'm checking a condition, right? And the condition is basically that v1 plus v3 equal to v2 plus v4. And if that condition is true, I print one message. And if that condition is false, I print another message. So let's write that now. If, right? And I'm going to put brackets here. v1 plus v3. And I would go so far as to even enclose this in brackets because like this is one expression, right? This is the left part of the comparison. Equal to, using the equality comparison operator, v2 plus v4. And that encloses this expression. And now I want to close the entire condition. So you can see that that's been closed correctly. Now I put the colon and say enter, and Python automatically indents the code that's coming below because it knows that after the colon, whatever follows is part of the if block, right? And if by chance it does not indent it for you, let's say it didn't, I'm pressing backspace to go back here. All you need to do is press tab, right? So you'll see your cursor move 4 spaces to the right. Now, if this condition is true, I'm going to print this message. First plus third equal to second plus fourth. So I'm going to say print first plus third equal to second plus fourth. Now, that's the only bit of code in the if block, right? So now I will go back to the level of the if and write the else block. So I'll press a backspace here. Now I'll say else colon, I'll say enter, and it automatically indents it again because now it knows that what code is coming is part of the else block. I'll say print first plus third not equal to second plus fourth, which is this message, right? So if this condition is true, print this message. If it's not true, that is in the else condition, you print this message. So let me run this using control enter. And now you can see that first plus third equal to second plus fourth is printed, which means that it's true, right? So it evaluated this condition, got the value true, and then said, okay, since it's true, I'm going to execute all the statements in the if block. Now, if I changed v1 to, let's say, some other value, 7, right? And I ran the same code again, it would have printed first plus third not equal to second plus fourth. Basically, it would check this condition now, realize that 7 plus 6 is not equal to 2 plus 5, and it would have gone to the else condition and executed the code under the else. So let me just change it back to 1 and run it. So we have our original message here. So you have if condition colon and then the if code block which is indented. Then you have the else keyword followed by colon and the else block which is indented. In this particular case, we are only testing if one condition is true or false. We're not testing multiple conditions, so we don't need an else if, right? Else if is optional. Else if is like elif is used if like there are multiple conditions, like marks are greater than 90, then between 70 and 90, between 50 and 70, and then finally less than 50, right? In this case, there's just true or false for this condition. That's why there's only if and else. Let's move on to the second exercise. For the same four variables above, that's these four. And remember, we've run this cell once, so these variables are already committed to memory, so I don't need to recreate them in this cell. If the first variable is less than the second and the third variable is less than the fourth, print this message, else print another message, right? So now I have two conditions joined by the AND logical operator. Now I explained AND in module 2, and it basically means AND returns true only if all the conditions evaluate to true. Otherwise it returns false. So I'll say if v1 less than v2 and v3 less than v4. That's my condition. And if I want, I can even enclose these individual expressions in brackets. That's your call. Then I put a colon and hit enter. And now you can see the code is indented. This is part of the if block. I'll say print this message. First less than second and third less than fourth. Right? And I press backspace now because I'm going back to the else block. Else colon enter. I'll print out the message if the condition is not true. This is the message, right? So if v1 less than v2, which gives us either true or false, and v3 less than v4, which also gives us a true or false, then the AND operation is performed between these two results. And if the output of that value is true, then the if block gets executed. Otherwise, the else block gets executed. So let's run it now. And you can see that the condition is not true, right? Because v1 is 1, which is less than 2. That's fine. But v3 is 6, which is not less than 5, right? So this part evaluates to false, while this part evaluates to true. Now, true and false is false, because the only time AND returns true is if both these conditions are true. Now, for example, if I changed uh, v3 to like 4 instead of 6, and now I rerun this, you can see that the if block gets executed because now the condition is true. That is 1 is less than 2 and 4 is less than 5. So this message gets printed. Let me just change it back to 6 and run the original code. You can see that the condition is not true. Okay, moving on to the third exercise now. Now ask the user to input a message, right? If the length of the message is more than 10 characters, print out that's a long message. Else print precise and concise. So I'm going to ask the user for an input and store that, and we know that the input function is there, right? The input function displays a message to the user and asks the user for an input. And when the user enters that input and then hits the enter key, whatever he's typed in gets stored in a string variable. So I'm going to say message equal to input, please enter a message, right? So the user will input a message and hit the enter key, and that entire string is stored in MSG, the variable. Now I want to type my if condition. So if, and how do I get the length of a string? It's using the len built-in function. Len of message greater than 10, right? So basically, if the length of the string is greater than 10, I want to print this message. That's a long message. And if the length of the string is less than or equal to 10, which is basically covered in the else condition, I want to print the message here, precise and concise, right? Now you can see that I'm asking the user for some input, and based on the user's input, I'm giving some specific output, right? So this is exactly what conditional logic is. Now if I run this, I'm asked for an input, right? Please enter a message. So I will say this is a test message, and obviously this is longer than 10 characters, so this is the message that should get displayed. So let me just say enter, and the output is that's a long message, which is basically what happens when the if block condition evaluates to true. So it's now printed that's a long message. Now let me run it again and show you what happens if I typed out a shorter message. So let me run this using control enter, and I'll just say test, right? And test is just 4 characters long. So len of test is 4, which is less than 10. So the else condition should get, the else block should get executed. Here we go. We get precise and concise, which is the code from the else block, right? So we ask the user to enter a message. We captured that using the input function, and then we check the length of that uh, string that we stored and checked if it's greater than 10 or less. Moving on to the next exercise. If the fourth item of the list, and this is the list here, north, south, east, west, if the fourth item is east, then print east is last. Else print west is last. Now, let me create a list variable called directions, right? And say it has these 4 values, north, south, east, west. Now, I want to check if the fourth item of the list is east, right? So in my condition, I'll say if directions, and how do I access a specific element in a list? I use indexing, right? And I use box brackets for that, and I supply the index of the item that I want. Now we want the fourth item, which basically has index position 3. So I'll say directions of 3 equal to double equals the string east. This is my condition, right? Directions of 3 equal to east. And remember to put the double equal to sign, because that's the equality operator checking for equality. It's not the assignment operator. So I'll put the colon here, and I'll say print east is last, right? Which is what I wanted here. Otherwise, so I say else print west is last. So if I run this now, it has checked whether the fourth item of this list is east, right? It's not east, so the if block does not get executed and the else block gets executed and this message gets printed, right? West is last. Now we know that the list has four items, right? So if I wanted to just say the last item of the list instead of saying index position 3, I could have just said -1, and that would give me the count would start from the end. This is what we call negative indexing, and the output would be the exact same, right? West is last. So I'll just change it back to 3. Okay, moving on to the next exercise. If the item north is in one of the first two positions of this list, and this is the same list, right? Directions which we created over here. So I won't recreate the list. I'll just use the same list from above. If the string north is in one of the first two positions, print first two. If it is in one of the last two positions, print last two. And if both the above conditions are false, print not present, right? So again, let me just for convenience sake, just have the directions list over here. We create a list with box brackets and we populate it with the elements that we want in the list. In this case, it's 4 strings west, right? This is our list. And now we want to check. And you remember now, so what happened is in the previous exercise, we used list indexing to access a specific element of the list. Now we want to check if this value north is in the first two, right? So we're taking a subset of the list. So we're using the subsetting or slicing operation. If north in, and we're using the in keyword to test for presence, right? We don't care about where it's present. We only care about whether it's present in the first two items, in the first two positions. Directions. And how do we slice this so that we get only two items? 0, 2, index position 2, because 2 is excluded, 0 is included, and it gives us the items at index position 0 and 1. Okay, now if I want to make this simpler, I can just remove the 0 over here. For now, I'll just keep the 0. So if north in directions of 0 to 2, then I print this value, first two, right? So if it's in the first two items of this directions list, I print first two. Now I press backspace, and in this case, I have an additional condition, right? If it's present in one of the last two positions, print last two. So I'm going to, in this case, use an ELIF, right? And after ELIF, I need to specify a condition again. Now the condition in this case is north in the last two items of directions. So how do I specify that? Directions of, so I want the second last and the last elements, right? So those are the last two elements of directions. So how do I specify the second last? I'll say -2, right? Using negative indexing. And how do I specify the last? I just leave this blank. I could also say 0, but I'll just leave it blank. Sorry, 0 would not work. I just need to say -2 colon blank. Now I put the colon for the ELIF condition and I hit enter. So now I have an indented block, which basically is the code block for the ELIF condition, right? So now I want to print this message, last two. And finally, if both the above conditions are false, print not present. So this is obviously an else block where there's no condition. It's like a catch-all. If all the previous conditions are false, then the else block gets executed. And I'm going to print this custom message saying not present. Let's run this and see what happens. So in this list, what it's telling us here, the output is that it's in the first two positions, which is true, right? North is the first element of this list. So it tells us that it's in the first two positions. Now, if I were to play around with this list and move north to the third position, then I would expect this first condition to be false and the second condition to be true, right? So if I run this now, it says last two, which is the output from the ELIF. And now if I do another experiment and I remove north from the list completely, then it says not present, right? So the else condition gets triggered. So let me just move it back to the first element and run it, and we get first two. So you've seen how to do if, elif, else, right? And the program is smart enough to figure out which of those conditions is true, and then it gives you the output accordingly. And you can see that just using such simple syntax, how powerful this program has suddenly become, right? Now let's move on to the last exercise in this particular section. So I'm going to create a dictionary with two keys having these corresponding values. So how do I create a dictionary? Using curly brackets, right? Curly brackets and key value pairs as the entries. So I'm going to say D equal to curly brackets, and key one is the string data type, colon, value one is the string with the letters int, right? Then I'm going to put a comma to say that I'm moving to the next entry of the dictionary. The second key is num letters, and the second value is 3. So I've created a dictionary with two keys, right? Data type and num letters. And their corresponding values are int and 3. Now I need to write a whole bunch of if, elif, else conditions, right? If the value corresponding to the key data type, that's this key, is string, print out the message 6 letters. If the value corresponding to this data type is float, print out the message 5 letters. And if that value is int, print out the message 3 letters. And if it's anything else, print out the message, no idea how many letters, right? So I'm going to write these conditions as such. If. Now, how do I access the value corresponding to the key in a dictionary? I use box brackets, right? I use that same indexing kind of format to say D of and the key that I want to specify. Either this would be a string key or an integer key. In this case, the key value is data type. If D of data type, that is, I'm saying retrieve the value corresponding to the key data type. If that is equal to string, right, the value string, not the data type string, colon, I'm going to print out the message 6 letters. Okay, so that's the first if condition, right? Now there are more conditions coming, so I'll put them under elif, right? Elif, and now what is the elif condition? If this value is float, print out the message 5 letters. So I'll just, if D of, I could have copied it, but let me just write it so that we get more familiar writing this, is equal to the string value float, colon, I'm going to say print the message 5 letters. Elif, another condition is there. If D of data underscore type is equal to int, the string value int, I'm going to say print 3 letters. And finally, if all these conditions are false, that is, the value corresponding to the key data type is something else, then I'm going to print out the message, no idea how many letters, right? So I've created these 4 different blocks. First is the if block, then there are 2 elif blocks, and finally there's the else block. And each of them has a different output, right? And each of them has a different condition. Now, according to this dictionary that we've created, the value corresponding to this key is int, right? So this elif block should basically be executed and the output should be the string 3 letters. Let's see if that happens. That's exactly what we get over here, 3 letters, right? Now, what happens if I change this int to string? Then the output also changes, right? It now catches this value as string and it prints 6 letters. Similarly, if I change it to float and run it, we get the output 5 letters, which basically means it's got this elif condition and executed this code block here. And finally, if we had changed it to something else, right? Let's say list, right? And run it, then all these conditions would have evaluated to false. And finally, it would have gone to the else block and this message would have got printed. So let me just change it back to int and run it. And we have the correct output, which is 3 letters. Okay, so you've seen how to write if, elif, and else conditions. You've seen how to specify the conditions in brackets, follow it with a colon, and then have an indented code block. And this at this point, we just have a code block with a single statement, but you can have any number of statements. Python will understand that they belong together by looking at the level of indentation. Now, we've taken care of these simple things, right, which are like if-else conditions. But there are cases where we have nested if-else. That is, an if-else within an if-else. So let's look at an example. And I'm sorry that this example is a little convoluted, but this is the best I could come up with, right? Let's say there are two dogs in the house. So there's a black colored dog called Jackie and a golden colored dog called Johnny, right? And let's say there are two cats in the house, a white color cat called Mickey and a golden color cat called Minnie, right? Use nested if else blocks to check the type and the color of the pet and print out the name of the pet, which is a golden colored cat. So, so how am I going to do this, right? So I have two basic variables that I'm checking out. The first is what is the breed of the pet, right? That is type of pet. Is it a dog or a cat? Now, if it's a dog and the color is black, I'm going to print out the pet's name is Jackie. If it's a dog and the color is golden, I'm going to print out Johnny, right? Similarly, if it's a cat and the color is white, I'm going to say Mickey. And if it's a cat and the color is golden, I'm going to say Minnie, right? So here's how I write it. If type of pet equals dog, then so this part is the code block of this top level if, right? So there is an if and an else which comes under this first if. So I'm saying if the type of pet equals dog, I'm getting into this entire logic over here, right? So the next level of checking is if the color of the pet is black, print Jackie, else print Johnny, right? And if the type of pet is not dog, that is basically it's cat, it goes to the else condition. And there again, I have a nested if else, right? So if color of pet equals white, print Mickey, else print Minnie. And now I want to check, right? I want to get the input from the user and I want to see like what is the output for different combinations of type of pet and color of pet. So let me just copy this entire code and run it here, right? So nothing's going to run because the variable called type of pet does not exist. The variable called color of pet also does not exist. So remember, now I can have any number of blank lines and Python doesn't care, right? It only cares about what is the level of indentation of this block, and on that basis it decides where does this block belong. So just before this, let me create these two variables, right? So first variable I'll create is type of pet, and I'm going to say for now equals dog, and color of pet equals, let's say, golden, right? So how does Python evaluate this? So if type of pet equals dog, which is true, right? So it enters this code block and avoids this code block. Now, if color of pet equals black, it prints Jackie, but the color of pet equals golden. So it avoids this code block and goes here, right? So it basically prints Johnny. Now, let's say I've changed this to cat, right? So now this first condition would have evaluated to false. So this entire thing gets avoided and it would have come to the else condition because this is the part where type of pet equals cat, right? And now it'll check here. The next thing it checks is the color of the pet, golden. So this condition is false. So Python avoids this execution and it comes here instead. And the output we get is mini. So let me run this. First, I run it in the case of a dog and the answer should be Johnny. And that's what we get over here. And then when I changed it to cat, the answer should have been mini, which is exactly what I get again, right? Now, if I want to make this a little more interactive, I can say I'll take an input from the user and say input, enter whether pet is a cat or dog, right? So the program is asking me for an input. And for color of the pet, I can take another input and say enter the color of the pet, right? And then based on the values that I input, it executes this code. So let me run it now. So enter whether the pet is a cat or a dog. Let me say cat, right? And I say enter. So this variable has been set to the value cat. Now enter the color of the pet. Let me say white, right? And the answer that it throws out is Mickey. The name of the pet is Mickey. That's because first it checked type of pet equal to dog. It was false. I had entered cat. So this whole thing is avoided. It comes to the else condition. Then it checks color of pet, which is white, right? Which is what I entered. So it prints Mickey. So let's cement this nested if-else thing in the form of an exercise. Now for each of the following inputs, check if a variable if the variable is a string or list, right? Now if it is a string, print the second character of the string. If it is a list, print the third element of the list. If it is neither of these types, print not a string or list. So let's say I have an input variable called IP, let's say, equals. In the first case, it's the value test, right? Now what I'm doing is I'm checking if the variable is a string or a list. Now, so I'm performing a top level check for string or list, and I'm performing another check if it's neither of these things, right? So first I'll say if, and how do I check for the type of an object? You remember in the beginning, in module 2, I had told you that every variable slash object has a type, an ID, and a value, right? So I can say type of IP to get the type of the input, right? And I can say type of IP is str or type of IP is list, right? And list and str are reserved words in Python that indicate the class type string in list. So I could have said this, right? But I'll also show you a more efficient way of writing it later. Now within this, wait, let me just say there's also an else block here, right? Which happen where the code that executes is if neither of these is true. So let me just write out that else block because I think you'll understand it easier this way. The message there is neither string nor list, not a string or list. And in the if block, we're performing a further check, right? We're checking if it's a list, we're doing something. If it's a string, we're doing something else. So let's say if type of IP is str, then we're printing the second character of the string, right? Second character of the string. And since we're printing one character of the string, we will use indexing. And how do you use indexing here? Using box brackets. So IP of 1, which gives us the character at index position 1, which is the second character, right? And if it's not a string, that is, it is a list, then I'm going to print out the third element of the list. So the condition here is, the code here is print IP of 2, right? IP of 2 is basically the third element of the list, which is what I would have printed. So I basically have an outer level if else where I check in the if condition that the input is either string or list. And if it's neither, then it goes to the else condition. And then within that if block, I have another if else, right? A separate one for string and a separate one for list. So for this input, what is the output that I should get? The first condition evaluates to true, right? If you remember the OR operator, it's a logical operator that we covered in module 2. The OR operator returns false only if all the inputs are false. If even one of the inputs is true, it returns true. Now in this case, type of IP is string. This condition is true, right? And this condition is false. So true or false returns true. And that's why it enters this entire block. Now it performs another check. If type of IP is string, which is true, so now it executes this print IP of 1, right, which is the second character of the string. So what is the second character of the string? E. So that's the output I should get. And that's exactly the output we get, E. So let me just change from test to this list value 1, 2, 3, 4, 5. So IP is now a list, right? So this condition still evaluates to true, but this evaluates to false, and so it goes to the else block. It prints out the third element in the list, which is 3. Let's run it and see if we get 3. That's exactly what we get, right? And now finally, we'll put a dictionary, right, with one key and one value. So if you think about it, the type is neither string nor list. So this entire block gets avoided and it goes to the else condition and prints out this answer. So let's run this. And that's the exact answer we get here. So I've used the type function. Let me just change this back to, let's say, test, right? Now I have written type of IP is str or type of IP is list. There is a much more efficient way to do this, right? So I can use the is instance function. Is instance, this variable IP, and since I'm checking for two types, I can supply a tuple containing both the values. One is str and one is list. So if IP is an instance of either string or list, then it comes here. And then again, I can use the is instance function, right? Instance IP of string. In this case, I'm only supplying a single value, so I don't need to put it in a tuple. And what we get here should be the exact same answer. In this case, we'll get the letter E, right? And if I changed it to a list, I would have got the third element of the list, which is 3. So I just used type of variable in one condition, and in this condition, I've used is instance. So it's just interchangeable, and you can use it according to your preference. And you can also remember that I use the is keyword to indicate if they refer to the same object, right? So if I say type of IP, I'm getting the class type and I'm checking if that class type is string or is list. And I'm basically saying, are they the same object, right? So that brings us to the end of if, elif, else, and we've also seen nested if else. So nesting is really, really important, and you just need to understand that there's an outer level and there's an inner level, right? So the outer level thing gets evaluated first, and then if that is true, then the inner level if and else get evaluated. Now moving on to the next section here, which is really, really important, because what happens is typically, like, if you think about data science, you're dealing with data, right? And like there's going to be multiple rows of data, not just one row. And there's also going to be multiple columns. So we are going to definitely need to repeat certain blocks of code multiple times, uh, depending on, let's say, the number of rows or the number of columns and so on, right? So loops are used to execute a block of statements repeatedly. And if you think about it, this happens in three primary ways, right? So one thing is me telling Python, as long as this condition is true, keep doing this particular action, right? For example, as long as there are more lines of text in a text file, keep processing these lines of text, right? So the condition here is as long as there are more lines of text remaining in the text file. And the action is process the lines of text that you have read. The second case could be repeat the execution of some a block of code a specific number of times, right? For example, print the value of a variable 15 times or 10 times. So I'm saying I want to run this print statement n number of times, and I'm specifying what n is. And finally, I would want to process, and this is the most important one, I would want to process all the elements of a sequence or a collection, right? Like I would say for all the items, like process all the items of a list which are numbers and find the sum of those numbers, right? Or print all the items of a list. So if you are repeating execution while a condition is true, you would use a while loop, basically saying while this condition is true, execute this code, right? So it's very simple. Like in if you had if condition is true, execute this code. Here you have while condition is true, execute this code. And in the second and third cases, that is, you want to run a block of code n number of times, or you want to process all the elements of a collection. For those two cases, you would use a for loop, right? And it's just like while. So for condition, execute code block. Here it's while condition is true, execute code block. Here you say for this condition, execute code block. Now again, just like in the case of if else, make sure you supply this colon, right? Make sure that the code block under the while loop or the for loop is indented, that is with either a tab or four spaces. Uh, Now, after you're done with this code block, right, the rest of the code comes to the same level as the while or the for. So like you have your overall program, you have your while loop at that same level as all the statements in the program. Then you have the code block under the while loop, which is indented by one. And once that code block is done, you remove the indentation and move back to the original level of indentation, which is zero, right? So let's look at while loops in detail. As I told you, while loops basically repeat execution while a certain condition is true, right? Now, here are some examples of how we can use the while loop. Print out the items of a list having index position less than 5. Or you can say, print out the list of positive numbers till and including a multiple of 8 is encountered. So you can very clearly see what the condition here is, right? The condition is index less than 5 in the first case, and while number not equal to a multiple of 8 is the condition in the second case. Now, when you're writing a while loop, there's one thing that happens to all beginners, which is you end up writing an infinite loop. Okay. Now, what is an infinite loop? It's a loop where the condition can never become false. It will always be true. And when does that happen? It happens when the variable that you're using inside the condition never changes, right? If you start with a value of 1 and you never increment the variable, then it will always have an index value less than 5, right? So the first thing you have to do is initialize the variable outside the loop and then process or increment the variable inside the loop. Let me give you an example of that. Now let's look at this example of print out the items of a list having index less than 5. So I have a list, right, with these multiple, let's say 6 items. I'm declaring the index equal to 0. Now this is the variable that I'm initializing outside the loop. And this is also the variable that I'm using in the condition of the while loop, right? So I'm checking while index less than 5, perform this particular code block, execute this code block. So I'm going to say print lst of index, which is basically saying print the list item at this position. Then I'm going to make sure I increment index so that I move to the next item in the list, right? Now, if I didn't increment index, index would always be 0. This condition would always be true, and it would become an infinite loop, and then you'd have to press this stop button to stop execution. So let's run this and see what happens. Copy it here, paste it here. So I have a list that I'm initializing. I have the index that I'm initializing. I'm checking if index is less than 5. If it is, I'm printing it and incrementing it, right? So what should I get here, right? While index less than 5, and I have the starting value of 0. So basically it prints out the items at index positions 0, 1, 2, 3, 4, right? Because the moment index becomes 5, then this condition becomes false, and we break out of the loop and move to the next statement after the loop. So let me run it here. And you can see that the items that have been printed are 10, 20, 30, 40, 50, which is the first 5 items, basically 0, 1, 2, 3, 4, right? And the list item at index position 5 has not been printed because that's the point at which the loop broke and the print statement did not get executed. So this is how while works, okay? Now let's look at the second instance that we had seen, which is print out the list of positive integers till and including a multiple of 8 is encountered. So what is the condition of the while loop? Multiple of 8 is encountered, right? So I just need to check if create a variable called multiple 8 and say it's false to start with, right? Because that's my starting condition, that I have not encountered a multiple of 8. And I will keep running the while loop as long as this condition is true. And the moment I do encounter a multiple of 8, I will exit the loop. So let's run this particular block of code and I'll explain what's happening. So first I'm initializing multiple of 8 to false, and that is the variable I use in the condition. Second is I'm creating, I want to print out the list of positive integers, right? So what is the first positive integer? 1. And x is the variable that I'm assigning to have these positive integers that I'm going to keep incrementing, right? So I say x equal to 1, multiple of 8 equal to false. Now, while multiple of 8 equal to false, which turns out this condition evaluates to true first, print the value of x. So in the first run, the value that gets printed is 1, right? Then it checks in this if condition. And remember, like you can also have an if condition without an else. Okay, it's not compulsory that you have to have an else. So if x mod 8 equal to 0, what does that mean, right? This is the modulo operator. What it does is it divides x by 8, okay, and it gives you the remainder. So for example, if I divide 1 by 8, 1 is basically 8 into 0 plus 1 as the remainder, right? So 1 mod 8 is equal to 1, which is not equal to 0. Now, if I increment, and then I reach, let's say, the value x equal to 8. At this point, x mod 8 is equal to 0, right? So then this multiple of 8 becomes true. And then the next time I go here, this condition evaluates to false. And then I break out of the loop. So I should ideally get 1, 2, 3, 4, 5, 6, 7, 8 printed out, after which it breaks out, right? Remember, like I'm checking for this multiple of 8 and I'm changing this condition after the print statement. So basically, even the multiple of 8 gets printed out, and then the next run, it breaks out of the loop. So let me run this. And this is exactly what I get, right? 1, 2, 3, 4, 5, 6, 7, 8. So it prints out the list of positive integers till and including a multiple of 8 is encountered. So just remember, there is a variable that you're using in the while condition. That variable has to be initialized before the while loop, and that variable has to be processed or incremented inside the while loop, right? So that it does not become an infinite loop. So we've seen the basics of a while loop. Let's do some exercises now. Now, using a while loop, print out the items of the tuple, and these look to be all squares of integers, having index less than 8, right? So I'm going to say t equal to this tuple, right? 1, 4, 9, 16, 25, and so on. And I have 10 elements in this tuple. So if I say print len of t, I get 10, right? Now I want all the elements having index less than 8. So what is my while condition? So first thing I'm going to do is index equal to 0. That's the starting point, right? The first index position in the tuple is 0. Now I'm going to say while index less than 8. So I will execute the code inside the while loop as long as this condition is true, right? I want to print out the items of the tuple. So I'm going to say print. And how do I get the item of the tuple from the index? I'm going to say t of index, right? So this is like the indexing operation for a tuple, very similar to that of a list. Then I'm going to do index equal to index plus 1, right? So I'm incrementing index, and that's it. So now I go here and I press backspace, and that's the end of it. So I should basically be able to print out the first 8 elements of the tuple, right? Because those run from index position 0 to 7. And the moment it becomes 8, then this condition becomes false, and then we break out of the loop. So let's run this. So len of t is 10, right, which is what we get here. And then I have the values 1 to 64, which is basically the first 8 values of the tuple, right? That is index position 0 to 7. Now, just letting you know, a more efficient way of writing the statement index equal to index plus 1 is index plus equal to 1, right? It's just like a better syntax, easier syntax to remember. We get the same output as before. Index plus equal to 1. So I initialized this variable that's being used in the condition. I then specified the condition, and within the while loop, I processed slash incremented this variable. Let's move on to the second exercise now. Using a while loop, print out the list of positive integers till and including the second multiple of 8 is reached, right? So I had shown you one example with the first multiple of 8. Now in this case, I'm going to look for the second multiple of 8, right? So let's say multiples of 8 encountered, right? And remember, I told you, in like, your code will become immensely more readable if you give meaningful names, right? So I'm going to say multiples of 8 encountered equal to 0, right? And this is the variable that I'm using in my condition. Now there's another variable that I'm going to use uh, just to, print out these positive integers, right? And that, let me say, is variable x. And what is the first positive integer? Equal to 1. So x has a starting value of 1. Now let's start the while loop. While multiples of 8 encountered less than 2, right? So the moment it becomes 2, then I want to break out, right? I want to print that and then break out. So I'll enter colon, and then I get into the while block, right? So the first thing I'm going to do is I'm going to print x. Then I'm going to check if x mod 8 equal to 0, right? That's basically checking if the number is a multiple of 8. So if x is a multiple of 8, I'm going to increment this variable. And I'm going to say multiples of 8 encountered plus equal to 1, which is basically saying I'm incrementing the value of that variable by 1, right? And then what I'm also doing is I'm incrementing the value of x so that I print out the next positive integer, right? And this is at the same level as the if. So x plus equal to 1. So now let's look at how it's going to run, right? So it starts with this value 0, and it starts with this variable for the positive integers 1. So in the first case, while multiples of 8 encountered less than 2. Now the initial value is 0, right? So this is true. So the loop gets executed. So it prints 1, then it checks if 1 is a multiple of 8. It's not. So this stays as 0. X gets incremented by 1 and it becomes 2. And so it keeps going like that until 8, right? Now at the value 8, this condition becomes true. And so this variable becomes 1 from the initial value of 0. But even in spite of it becoming 1, this condition is still true, right? And then it runs again from 8 to 16. And when it becomes 16, 16 has already been printed here. But now the multiples of 8 encountered becomes 2 from the value 1, right? And now it checks if this condition is true or false. Now it's false, so it breaks out of the loop. So let's run it. And there we go. We've got values 1 to 16 printed out, which is basically the second multiple of 8, right? So we've got this while loop, initialized the variable in the condition outside, used the variable inside the condition, and also incremented it within the while block. So continuing our kind of understanding of loops, right? There might be times when we want to perform certain special operations within a loop, right? Now we know that the while loop executes as long as the condition is true. But there are some things that I might want to do. For example, in certain instances, I might want to skip certain statements, right? And just go back to the beginning of the loop, or rather to the next iteration of the loop. And the way to do that is the continue statement, right? So this is the statement I would use to basically say when Python encounters the keyword continue, it ignores the rest of the block of code inside the loop and then goes back to the next iteration of the while loop. For example, I want to print all numbers less than 100 that are not multiples of 6, right? So what I would do is in my condition, I would say variable value less than 100, right? But I would also have an if condition inside that where I checked if it's a multiple of 6. And if it is a multiple of 6, I'll just type continue so that the rest of the code is ignored. So if you see that here, this is basically the code for it, right? Num equal to 1. So that's since I want to print all numbers less than 100 that are not multiples of 6, and I'm looking at all positive numbers, right? So num equal to 1, and that's the initialization. I'm saying while num less than 100, right? Now, if it's not a multiple of 6, or rather, if it is a multiple of 6, I'm just incrementing num, and I'm typing continue, which basically ignores the two next statements and goes back to the beginning of this loop, right? Where it checks the condition again. Now, if this if block evaluates to false, then what's inside does not get executed. Instead, it prints the number and increments the number by 1. So basically, this print statement is the one that is either being avoided or not, right? Because even inside the if block, the num plus 1 is happening. Like in all instances, I'm incrementing num, but it's only if this condition is true that I press continue and I avoid the print statement. So basically saying in this case, multiples of 6 will not get printed. Let's run this code and I'll show you how it works. So ideally I should get values like 1, 2, 3, 4, 5, then 6 gets skipped, and then 7, 8, 9, 10, 11, then 12 gets skipped and so on, all the way up till 99. And that's exactly what we have, right? So 1, 2, 3, 4, 5, then jumps from 5 to 7 because when it encounters 6, I've written the continue keyword and print does not get executed. And it goes all the way till 99 because our while condition states that num less than 100. Now let's look at another case, another kind of loop control statement, right? We've already seen continue. Continue like skips the rest of the while block and goes back to the beginning of the loop, which is where it checks the condition. Now, there are other cases where I might say that if I encounter a certain condition, I want to just break out of the loop. Like I want to ditch everything and just get out, right? And that's the break statement. So, for example, print out all items of a list till you encounter a value greater than 100, right? And we can use a break statement here. So how that works is, let's say I have a list, right? And these are all multiples of 25. So the first four values are less than or equal to 100, and the last two values are greater than 100. Now, let's say my index is 0, right? And in this case, what I'm saying is keep printing out elements of the list till I encounter a value that's greater than 100, right? So there's two ways of doing this. I'm going to show you the method where I use the break statement. So now this is another important concept to remember. I'm creating an infinite loop, right? In my condition, I'm just putting the number 1, which where I could have also said I could have put the Boolean value true, right? Because the condition always evaluates to true. And what I'm then doing is inside the loop, I have a break condition so that there is some way of exiting the loop. So if LST of index greater than 100, I break, right? If it's not greater than 100, I print the value of LST of index and I increment index by 1. So in a sense, I would have used index in this, like what would normally have uh, LST of index would have been in the condition here, right? But instead of that, I'm putting true in that condition here and I'm moving it down here into the if statement. And that's where I give my break statement. So what I'm saying is while 1 evaluates to true always, then I check if LST of index, in this case that's LST of 0 greater than 100, I break. So for the first run, it's false. So it just prints the value, increments the index and moves on. Second value, third value, fourth value, this if condition is again false. Now when it goes to the fifth value, that is index value 4, LST of index is greater than 100, right? So now the break statement gets executed and it ignores everything else here and then comes out of the loop, and this is the next statement out of the loop and it gets printed. So let's run this particular code and see what happens. So ideally here, these four values should get printed because they uh, satisfy the condition. And then because I've used break for values greater than 100, these two should not get printed. And then finally, the value outside the loop should get printed. So let me run it. And that's exactly what happens, right? You have 25, 50, 75, 100, and then out of loop. So another way of writing this would have been like if I didn't want to use the break statement, like I just want to kind of demonstrate how break works, right? But if I didn't want to use it, I would have just done while LST of index less than equal to 100, do this, right? And I would have got the same output. Basically print LST of index and increment index by 1. So I get the exact same output in this case. So in one case I used break, in the other case I didn't use break. Now I've shown you continue, which basically skips the rest of the statements and goes back to the next instance of the loop, next iteration of the loop. I've shown you the break statement that just breaks out of the loop and then continues to execute the first statement after the loop. And now there are times when like I want to run a loop a certain number of times, and at the end of the loop I want like some actions taken. Like for example, if there was a counter that kept getting incremented in the loop, I want to reset that counter to 0 or 1, or I want to print out the message saying loop is now closing, right? And that's where I use the else statement for a loop. So when I used it in conjunction with the if statement, the else statement was what got executed if all the other conditions were false. But in this case, if I use it with a loop, the else statement is what gets executed once the loop is done running. Let's look at it here, right? So I say counter equal to 1, right? And while counter is less than 10, I print it out and increment it. So basically, I'm printing out values from 1 to 9, right? And once it becomes 10, this condition becomes false, right? And the loop execution is done. But before breaking out of the entire loop, it executes what is there in else. It resets the counter to 1 and it prints the message loop closing, right? And now it goes to the first statement after the loop. And these two things also get printed. So the value of counter that should get printed is 1 because it got reset in the else clause. So let's run this code and see how it executes. So ideally, first I should have values from 1 to 9. Then I should have the statement loop closing. Then I should have the statement after loop. And then I should have the value 1, which is the value I reset the counter to. Let's run it and see if that's what happens. That's exactly what happened. We have 1 to 9. Then we have loop closing, which was here in the else clause. Then we have after loop, which was the first statement after the entire while loop and else. And then we have the value of the counter, which is 1. Cool. So that's how you use these loop control statements that are continue, break, and else. Okay, so let's do a couple of exercises now. Use a while loop with break to print out squares of integers greater than 0 with the square not exceeding 100. So what am I saying? Like I could have done this two ways, right? Like first one is my condition itself is that the square of the integer should not be greater than 100, basically less than equal to 100, right? That would have been like a straightforward way of doing it. But I want to use the break statement. So how will I do it? I will create a loop that where the condition is always true, right? So it's an infinite loop. And within the loop block of code, I will check if the square is greater than 100. If it is greater than 100, I'll break out of the loop. Okay. So I'll show you first how to do it with the break statement, then I'll show you how to do it without. So, or actually let me do the reverse. Let me show you without the break statement first, right? So I'm going to say x equal to 1, right? This is the number that I'm going to square. Print out squares of integers greater than 0. So x equal to 1. Now while true, right? Or while 1, this is what gives us an infinite loop. And this is what I would have used if I were using the break statement. But in this case, I'm just checking if x square, that is the exponent operator, right? So this double star is the exponent operator and 2 is the power. So while x power 2, that's x square, less than equal to 100, that's my condition. I'm going to say print x square, and then I'm going to say increment x by 1, right? So I'm starting with 1. I'm just going to keep going 1 square, 2 square, 3 square, 4 square till x square becomes greater than 100, in which case I break out of the loop. So let me run this, and this is exactly what I get, right? Squares from 1 to 10, which is basically 1 to 100 in output. Now let me show you how to do the same thing using the break statement. So for the break statement, I'm going to run an infinite loop. So I'm going to say while 1, right? And I'm going to check if x power 2 greater than 100. What am I going to do? I'm going to break out, right? And if it's not greater than 100, then these statements get executed. Let's run it now, and I should get the exact same output. That's exactly what happens, right? So remember, I'm still incrementing x, I'm still printing these things out, but just before that, I'm putting a if condition where if that condition is true, I'm breaking out of the loop, right? Now let's move on to the second exercise. Use a while loop with continue to print out all positive integers less than 25, so basically 1 to 24, which are not multiples of 3. On top of that, I'll also use an else statement containing something else, but let's get to that second part later. Let's do the first part now. Print out all positive integers less than 25, which are not multiples of 3. So basically, I have to check if it's a multiple of 3. If it is a multiple of 3, I type continue so that it doesn't execute the print statement. And if it's not a multiple of 3, then the print statement gets executed. So I'll say x equal to 1, right? And this is the variable that I'm using to like go from 1 to 25. So while x less than 25, I'm going to say if x modulo 3 equal to 0. So basically I'm checking if x is a multiple of 3. Then I'm going to type continue, right? And the rest of this while block code, indented code, does not get executed. But if it's not a multiple of 3, the rest of the code does get executed. And what I'm going to do is I'm going to print x and I'm going to increment x, right? So let's run it. And I think I've goofed something up. While x less than 25. So if x is a multiple of 3, I say continue. Oh, okay. Uh, Again, I just showed you. I'm going to interrupt the kernel here using the stop button. And what happened is this, it got into an infinite loop, right? And why did it get into an infinite loop? Because I didn't, so because the if condition turned out to be true, continue got executed, but x did not get incremented, right? So x kept becoming 2 and it just kept going in this infinite loop. So I have to increment x also within this if statement. So if x is a multiple of 3, I'm going to increment x and then I'm going to say continue and go to the beginning of the loop. Let's run it now. And this is what I get, right? Numbers less than 25, which are not multiples of 3. So 1, 2, then I've skipped 3, then I go to 4, 5, I skip 6, and so on. Cool. So you've seen how to use a while loop with break, and that's typically used when either the condition, you can have an infinite loop or not, but basically you're checking if a condition is true and then saying break based on that condition. And we've also seen while with a continue, if you want certain things to like be skipped over, right? And this is the condition for which the print statement is skipped over. And I also wanted to use an else statement in the above loop to print loop closing before exiting the loop. And how do I perform a last operation before exiting the loop? I use else, right? And else is at the same level of indentation as while. So in this else clause, I'll say print this message, loop closing. And then I'll say after the loop, so now if I run it, the else clause gets executed here, and then this statement of this comes after the loop. Okay, moving on to the next exercise. Create an infinite while loop which asks the user for an input repeatedly and only terminates if the input value of the string is the word enough, right? So there's two ways again to do this, right? We're looking for a condition on which to break. So either I can do a thing where I check, like within the while condition itself, I check if the string value is enough. And if it turns out to be false, I break out. Or the other thing I can do is I can create an infinite loop and use the break statement. So first I'll show you how to do it without break, and then I'll show you how to do it with an infinite loop and break. So I'll say I'm going to take an input from the user, right? X equal to input, enter a message, right? Or actually, let me just say, uh, I'll keep this within the loop, right? So I'll say X equal to empty string, right? While X not equal to the word enough, I will execute the following code. I will ask the user for an input and then put that in the variable X and then check if it's not enough, right? So if the word is not enough, I will keep running through this loop and I will keep asking for a message, and the user has to keep typing a message until he types the word enough, at which point this condition becomes false and we break out of the loop. So let's run this. So the reason I initialized it to this value is because I'm using it in the condition, right? So I'm just putting it in such a way that this initial condition evaluates to true. Then I get into the loop and I start asking the user for the input. So let's run this. It says enter a message. Let me say test. Again, it asks for enter a message because this condition was false. I'll say check. Again, it's false. Now I'll say enough, right? And I'll say enter. Now the loop execution terminated. So it's no longer asking me for any messages. So this is one way of doing it, right? Now the other way is to just, I can remove this statement. I can run an infinite loop. And within the infinite loop, I can just check if this condition is true. So I'll say input a message, and if x is equal to enough, I will use the break statement, right? And if it's not equal to enough, I loop back over here. The loop evaluates to true. Then again, I ask the user for an input message. Let me run it in this particular way. So it asks to enter a message. Let's say test. And this does not get executed because I did not enter the word enough, right? So now I'll say enough and hit enter. And now the basically the condition evaluates to true and the break statement gets executed, and then we break out of the loop. And it's no longer asking me to enter this message. So we've seen how to use the while statement, the while loop, right? Basically loops repeatedly while a certain condition stays true. Moment the condition becomes false, we break out of the loop, right? We've also seen loop control statements like continue, break, and else. Continue skips the rest of the while block and goes back to the beginning. Break just entirely breaks out of the loop. And the else statement is what uh, code gets executed at the end of the loop execution before going back to the main program execution. So now let's move on to the for loop. I told you that there are three primary use cases, right? And the while loop took care of one of those use cases, which is keep repeating a block of statements while a condition is true. Now there are two other conditions. One is to repeat a block of code n times, and the other one is to iterate all over the iterate over all the elements of a sequence. And for this, we use the for loop, right? And the format is the same: for condition colon execute a block of code. So how do I repeat a block of code n times, right? uh, I've shown you the range function, right? As part of lists, I've shown you the range function. And what the range function does is I specify range of m comma n, right? And uh, it basically gives me integers from m to n minus 1. Now, if I don't specify m and I only specify n, then Python assumes m to be 0. So basically goes from 0 to n minus 1. Right? So range of 10 will give me the values 0 to 9. Range of 1 comma 11 will give me the values 1 to 10. Basically 11 is excluded, right? So that's range function is what we use to execute a block of code n times, right? So let's say I want to print out all the values of x and I'm basically going from 0 to 4, right? So I'll say for x in range 5, right? And range 5 basically means the values 0 to 4. So print this particular statement, right? The value of x is, and then you concatenate with string of x. So let's run this. And what we get is 5 print statements, right? So for x in range 5, right? So then Python breaks down this code and it figures out that range 5 actually means 0, 1, 2, 3, 4, right? It figures out that these are the values in this collection sequence. So first it gives x the value of 0 and then it executes this block of code, right? So you see this statement over here. Then it gives x the value of 1 in the next iteration and it prints it out and you get this, and so on 2, 3, 4. And then when it reaches the value 5, it breaks out because, or rather it never reaches the value 5 because it's evaluated this sequence slash collection to only contain these values. So when it reaches the end, it breaks out. Now, let's say I want to print out the message hello world 5 times, right? So I can just do it a very similar way. In this previous case, I use the value of x. In this case, I'm not using the value of x inside the for block. So I'm just saying print hello world. And you can see that hello world gets printed 5 times because x goes from 0, 1, 2, 3, 4. And each of those times I print out this message. Now, what if I want to print out even numbers between 1 and 10? So I say for x in range 1 to 11. So 11 gets excluded and the numbers that get returned are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And within that for loop, I check if x mod 2 equal to 0, I print it, right? That is basically saying if x is divisible by 2, that is if x is an even number. So I'm printing out even numbers between 1 and 10 using this code. Let me copy and paste it. So I should get 2, 4, 6, 8, 10 as the output. And that's what we get over here. So for x in this range, and in each iteration, it executes this code for that particular value of x. So the first value of x is 1, right? 1 mod 2 is not equal to 0. So the print does not get executed. Then it moves to the next value of x, which is 2. Now 2 mod 2 is equal to 0, so it prints it. So every even number gets printed, every odd number does not get printed. And finally, print out the first 10 positive integers with this custom message, right? And I've just printed like the message in 2 different ways. One is using concatenation and converting x to a string using the string constructor. The other one is using an f string, which I told you about in our module 3 video on strings. When I say f before the string, I can just embed a variable inside the string and I don't need to use dot format and so on, right? So the variable is x over here and it takes this value of x and dumps it in this string. So print the first 10 positive integers. Now, which are the first 10 positive integers? 1 to 10, right? So I say range of 1 to 11 because 11 is excluded. Now, if I run it, each statement gets executed twice, right? One is this and one is this. Let me just remove this one. And if I run it, I have 10 print statements that get executed. And in each of these, the value of the variable x is embedded here. Let's do some exercises to go over like how to execute a block of code a specific number of times, let's say n times, using the for loop, right? Print the following statement 5 times. This statement is repeated 5 times. So I'm going to copy this statement. I'm going to say for x in range 5, right? For x in range 5 means it goes from 0, 1, 2, 3, 4 and basically gets executed 5 times. And I'm going to print the statement. Let me run it and you can see that this statement is executed 5 times, gets executed 5 times. So for x in range 5. Now print out the negative integers from -10 to -1, right? It's an interesting problem. So for x in range, what is the starting value? -10, right? What is the ending value? -1. So I'll go one higher than -1, which is 0. And you remember that I can give 3 arguments to the range function, right? M, N, and S. So it goes from M to N minus 1 in steps of S. And the step I want is 1. So 1 is by default, so I can just, like, let's say, leave it empty for now. For X in range -10 to 0, so basically it goes from -10 to -1 and 0 is excluded. Print X. Now if I run it, I get -10 to -1 printed out correctly. Cool. Moving on to the next exercise. Write a for loop to print out even number followed by the actual number if the number is even, and odd number followed by the actual number if the number is odd. Do this for the first 10 non-negative integers. Now, which are the first 10 non-negative integers? 0 to 9, right? So I would say range 10. For x in range 10, that gives me the first 10 non-negative numbers. Now, what do I want to check? I want to check if x is even. If x is even, I want to print out one message. If x is odd, I want to print out another message. So I'll say if x modulo 2 equal to 0, then I will print even number plus string of x, right, which is the actual number. Else, if basically saying it's not odd, or rather not even, I will print this message, but saying odd number, right? So for x in this range, that is the first 10 non-negative numbers, if it's an even number, I print out this message. And if it's an odd number, I print out this message, and that's the end of the loop. Let me run it. And you can see what happens. Even number 0, odd number 1, even number 2, odd number 3, and so on. So it's giving you conditional output based on this particular condition, and it's running it n number of times that you specify. Now write a for loop to print the square of integers from 1 to 10. So I have integers from 1 to 10. So how do I specify them? Range 1, 11. So for x in range 1, 11, so 11 gets excluded. I want to print the square of integers. So print x power 2, right? So if I run this, I get 1 to 100 printed out, the squares. I could have also said power of x using the inbuilt function x comma 2, right? I get the same output. So we've seen how to run a for loop a specific number of times using the range function. Now the other time I want to use a for loop is uh, to iterate over all the elements in a sequence or collection. Now, which are the sequences and collections that we've encountered? We saw all of them in module 3, right? We saw list, string, tuple, dictionary, and set. So if you want to iterate over all these and get all the elements, then we use a for loop. So let me show you how to loop over a string, right? So let's say I initialize a string with this value. Now, one way of doing it is saying for char in s. So, or whatever variable name in s, right? S being the string, print variable name, right? So I'm saying for each element in the string, print that element, right? And this is the most straightforward way of doing it. But the other way you could do it is using the accessing the string elements using the index. So instead of saying for char in s, I'll say for char index in range of length of s. So how does that work? What is the length of s here? Let's say hypothetically it's 15. Okay. So range of 15 will give me numbers from 0 to 14, right? And those are basically like index positions. And I can map that index position to the index position of the string, and I get that particular character at that index position. So let's run this example and it'll become a lot more uh, evident how this works. So I'll just comment out the second part. So I should basically, with this code, I should get each character of the string printed out separately, right? For char in s, print char. So you can see that in the first line, s gets printed. In the next iteration, t gets printed, then r, and then so on, right? So one by one, I print out the characters. And literally, this could have, it's not like char is some special word. I could have said for x in s, print x, and I get the same output, right? Now, the other way of doing it, let me comment this out and uncomment this, control forward slash. For char index in range of len of s, right? So let me just first print out len of s. And what I get is 17. So the length of the string is 17. So what I'm saying for char index in range of 17, that basically gives me the numbers 0 to 16, print s of char index, which is basically like indexing, right? Indexing to access a specific element of the string. And this is what I get here. Individual elements of the string printed one character per line. So I've shown you how to loop over a string. Now, I'll also show you how to loop over the other collections, right? So let's see how to loop over a list now. It's the exact same way. One is you say for item in list, you print the item. The second one is you say for item index in range of the length of the list, you print list of item index. It's almost like the exact same thing as what we did for strings. Let's copy this here, paste it here. And you can see that the output you get, like, or rather the way you get the output is almost the same as strings, right? So I have this list with 5 values. I'm going to say for item in list, print item. So it replaces this with this and it goes one by one, right? First time it assigns item the value 10 and then it prints 10. Then it assigns it in the next iteration the value 20 and it prints 20 and so on all the way till the end of the list. So let's run this and this is exactly what you get. One by one the items are printed out. And if I comment this and I run it out using the index access method, so all I'm doing is I'm saying, like in this case, let's print out the len of LST, right? The length is 5. So when I say for item index in range 5, I'm basically saying iterate from 0 to 4. So in the first run of the loop, item index has the value 0, right? And LST of 0 is 10. In the second iteration, it has the value 1 and LST of 1 is 20. And that's how these values get printed. Now, tuple and list are literally almost the exact same in terms of access. The same way I go for item in tuple and I do for item index in range of length of tuple. And in this case, I have a tuple with 6 elements, right? So over here, it just goes element by element and picks them out like 2, 4, 6, 8, 10, 12, whatever, one by one. And in this case, the item index starts with 0, then it goes to 1, 2, 3, 4, and ends with 5 because the length is 6 and the last index position is 5. So it goes from 0 to 5. And it says tuple of index. So first case, tuple of 0, then tuple of 1, and so on. So if I run this, I get 2, 4, 6, 8, 10, 12 printed from this code, and then I get the same output printed from this code, which is here. So list, tuple, string, the access is almost the same, right? The first way is saying for item in collection, print item. The second way is saying for index in range of the length of that collection, print item of index, or rather print collection of index. Now let's see how to loop over a dictionary, right? This is interesting. So what I'm doing is I'm initializing a dictionary here with 3 keys and 3 corresponding values, right? So key 1 colon 100, that's the first entry. Then I have key 2 with the value 200 and key 3 with the value 300. Now the first way of doing it is I've shown you, right? Like there are some dictionary methods, right? The dot keys method gives you an iterator of all the keys in the dictionary. The dot values iterator gives you all the values in the dictionary, and the dot items iterator gives you an iterator of all the key value pairs in the dictionary, right? So in this case, I'll say for key in dictionary dot keys, and dictionary being our object here, print this message, right? So key equal to key and value equal to object of key. This is basically dictionary access. It's like indexing. It's like how I access the value corresponding to the dictionary item, the dictionary key with the value key. Now, the method 2 for accessing it would be directly using values, right? Here I've used dct.keys. I'll say for value in dct.values, print value. So I'm accessing the values of the dictionary directly. And in the third method, I told you, you have keys and values which are combined into tuples in which are returned in dct.items. So I say for key comma value in dct.items. So I'm saying for a tuple in this entire set of tuples, print out these values one by one, these pairs, right? So let's run this and see what output we get. Now for the first thing, this is the message when I access the keys. This is the message that I got, right? And that's been printed 3 times because there are 3 keys. In the second case, I directly accessed the values and printed them one by one, which is where I got 100, 200, 300. And in the final case, I accessed these tuples, these key value pairs, right, using dct.items. And this is the message that I got in 3 different lines. So I've shown you how to access strings, list, tuple, and dictionary. Not just access, but like how to loop over them. So let's do some exercises now. Use a for loop. Print out all the individual characters of the string test string number 1 that are not E. Okay. So I'll do this with and without the use of the continue keyword. So I'm going to say S equal to this string, right? And I'm going to say for C in S, that is for character in S. And each element of the string is basically a character, right? So if C is not equal to E, I'm going to print C. That's it. So I want to print out all the individual characters of the string that are not E. So if C not equal to E, I print it, right? So let's run it. So I get test string number 1, and the letter E is missing. So I just get TST. So I've done this without using the continue keyword, right? So if I wanted to use the continue keyword, I would have done if C equal to E, continue, right? So, and then I would have said print C at the bottom here, at the same level as the if. So for each character in the string, if the character is E, then continue and go back to the beginning of the loop to the next character. Else you print this character, and I should get the same output as the previous case, which is exactly what I get, right? The letter E is missing. Now using a for loop, print out the squares of all numbers of the list 10, 20, 30, 40, B until you encounter a non-number, right? And we have a non-number which is B. And I'm going to do this using break, right? Because like a while loop would have been awesome for this, because I'm saying do this while the input is a number. But I can also do it using a for loop. I'll say L equal to this particular list, right, which I copied from there. Now for item in L, if item, and so what are the number data types? It's either integer or float, right? So I'll say if is instance item, and I'm going to supply a tuple, right, with the two data types that I'm looking for, int comma float. If item is an instance of int or float, then I'm going to uh, print out the value. But in this case, I want to achieve this thing using break, right? So let me say if, and how do I reverse a condition, right? Like if this is true, how do I reverse it? I use the not logical operator, right? Not of this will give me the opposite of it. So if it is true, it will give me false. So basically, if it does not belong to these two data types, then what you do is you break out of the loop, right? But if it is one of those, then all I'm going to do is I'm going to say print item to the power of 2. So I'm going to print out the squares of all the elements of this loop, of this list, until I encounter a non-number. So for item in this list, if the item is not an int or a float, I'm going to break. And if it is an int or a float, then this does not get executed, and I just print out the item square. I don't need to do any incrementing here because the for loop takes care of that incrementing for me automatically. In the while loop, I have to manually do the incrementing. So here you can see that I've got the squares of these numbers, and the moment I encountered a non-number, it broke out of the loop. Just to show you that, I can say print after the loop, right? And if I run it, it's printed the next statement after the loop when it encountered the value B in the list, because this condition became true and it encountered the break statement. Okay, using a for loop and iterating by index, print out the squares of all the elements of the list 10, 20, 30, 40. So I'm going to say L equal to 10, 20, 30, 40, which is a list. And I'm going to iterate by index, right? So if the list has 4 elements, what are the indexes of those elements? 0, 1, 2, 3, right? And how do I get that? Range of 4. And in this case, it's the range of length of L. So for index in range of len of L, that's range of 4, which is 0, 1, 2, 3, print L of index, that is the element of that list, square. Okay, so let's run it. And I get my expected output. So instead of directly iterating over the elements of the list, I'm iterating over the index numbers and I'm then accessing those elements using L of index. Now using a for loop, print out the indexes and elements of the list A, B, C. So how do I get indexes and elements? I would use the enumerate function on that list, right? So let's create this list L equal to ABC. Now I want to print out the indexes and elements, right? And this is usually in the form of a tuple. Let me just print out that list of enumerate. So I'm passing the enumerate output of L into a list, right? And then I'm printing that out. So if I print out that list, you can see that I get a set of pairs, right? The first position in the first item of that pair is the index, and the second item of that pair is the value. So I get like index value pairs. So what I'm going to do is for I comma v, that's, or rather let me say index comma value, and this is in the form of a tuple, right? So I'm saying for this tuple in this list, print index value, and let me just put this as an f string, index value, and I'm going to embed the variable index from here, comma, corresponding value, and the variable value here from here. Okay, so let me run this, and I have an indentation error. So I've wrongly indented this. So for should come here, and the print should be indented by one tab, right? So let me run this now. And there are three elements in the list, right? So enumerate gives me three pairs of values, index value pairs. So in the first pair, index value is 0, corresponding value is A. In the second case, it's 1 and B. Third case, it's 2 and C, right? Which is exactly what I wanted. So I use the enumerate function to enumerate this list. Then I passed it to the list constructor, and then I iterated over each of those tuples using index comma value. So you need to know beforehand what the structure of that tuple is going to be. Like for example, if I zip three lists, right, then each tuple is going to have three values inside. So I'm going to have to say value 1, value 2, value 3 over here. In this case, there are only two values, so I could say index comma value. And finally, print out all the keys and values of the dictionary. Key 1, India. Key 2, China. Key 3, Russia. So I have a dictionary that I'm initializing with these values. I want to print out all the keys and values of the dictionary, right? Now, one way of doing it would be accessing the key value pairs using dictionary.items, right? I've shown you that method before. So for this tuple, key, comma, value, and these are variable names, right? In d.items. D.items is a iterator of key value pairs in the dictionary. Print key, comma, value. If I run this, I get key 1 as the key and value as India. Then key 2 is China, key 3 is Russia. So I'm printing key value pairs and I'm accessing it as a tuple from this iterator of d.items. So that brings us to the end of the part where you iterate over a collection or a sequence. Now the last thing we look at is nested for loops. I've shown you already nested if-else conditions. Now we look at nested for loops, right? And how does this happen? Like there are cases where you have a list of lists. You can have like a dictionary with the key values as either strings or integers, but let's say all the values corresponding to those keys are like lists, right? So then you would need one outer for loop to iterate over the keys of the dictionary. And when you retrieve the value corresponding to that key, you would need a second inner for loop to iterate over that list, right? For example, if I had this list here, right? The outer list has only three items. The first item is this list, the second item is this list, and the third item is this list, right? But each of these items in turn has multiple items. So I need the first for loop to access the items of the outer list. And then I need a second for loop to access the items of each of these inner lists. And it's the same thing in the case of this dictionary. The outer for loop will go through the keys, and the inner for loop will go through the values of these lists. So how do I iterate over a list of lists? Let me say I initialize the list with these values, right? So I say for index comma inner list in enumerate of list. This is just a complicated way. Let me show you an easier way. If I run this, I just need to say for inner list in LST, right? So it gives me each of these inner lists one by one. Let me delete this statement. And for item in each of these inner lists, print item, right? So the first inner list it gives me is this one. And the first item it gives me is this value within this inner list, right? So if I run this, I get all these values printed one by one, right? Now the previous case would have been like what I was doing is I was also saying enumerate of this list, enumerate of the outer list. So it says at index position 0, I have this list. At index position 1, I have this list and so on. First, I'm printing that list number, which is the index position number, and then I'm iterating over the list itself. So if I do it here, first I get list number 0 and the values within list number 0, which are printed in this inner for loop, which is 1, 2, 3. And in list number 1, you have 4, 5, 6, 7, right? Now, if I had to use nested for loops to iterate over a dictionary, what I would do is, first thing is for key in dictionary.keys. So that would give me a list of all the keys. And then I would say for item in dictionary of key. So this DCT of key is a way to access the value corresponding to that key. So I'm iterating over all those values. If I run this here, the output that I get is for key 1, I have a list with the values 1, 2, 3, 4, 5, which are printed here, right? I could have also just like commented the statement and I would have got a simpler output where just one by one I print out the elements of the inner lists. So I'm using an outer for loop to go through the keys and the inner for loop to access items in those lists corresponding to that key. Okay, let's do an exercise now. You have a list of lists, right? And this is the list of lists. Let's say L equal to this value. Create an output list where each item is the sum of corresponding input list items at that position. I'm giggling because my wife just did something funny, but it's okay. Let's go on. Create an output list where each item is the sum of the corresponding input list items at that position, right? So let me actually call this input underscore list. Now, what does the question actually mean, right? The output list has, now the input list has how many items? 1, 2, 3, and 4. It has 4 inner lists, right? So the output list should have 4 items where each item is the sum of these inner lists at that position. So ideally the output list should be, what is 1 plus 2 plus 3? That's 6, right? What is 4 plus 5 plus 6? That's 15. 7 plus 8 plus 9 is 24. And 10 plus 11 plus 12 is 33. This is what the output list should be. Okay, so that's what I'm going for. So let me just instantiate it as an empty list. So now I need to iterate over the outer list and then sum up the values in the inner list. And then I'll use the append function to add it to the output list. So I start off with an empty list and then I append values one by one. So for inner underscore list in input underscore list. So I'm creating a variable called inner list, which will hold these inner lists one by one, right? Then I'm saying there's a second list called, uh, so what I'm also doing here is I'm initializing a variable called sum of items equal to 0, right? Then I'm saying for item in inner list, and inner list is what I got over here in the outer for loop, sum of items plus equal to item, right? So it's like I'm saying for each list in this input list, first say the sum is 0, and now for each of these items I'm adding that item's value to the sum, right? And then at the end of it, once this loop is completed, sum of items contains the sum of each individual item for that inner list, right? So I'm going to append that value to the output list. So let's say output underscore list dot append sum of items, right? And at the end of it, I'm just going to print output items, output list, sorry. Let's run it. And this is exactly what we get, 6, 15, 24, 33, right? So 6 is the sum of this inner list, 4, 5, 6 is the sum of this, 7, 8, 9 is the sum of this, and 10, 11, 12 is the sum of this. So for each inner list in the input list, set the sum to 0, then go item by item and add that item to the sum. And then whatever the final sum is, you add that to the output list. That's what this code means, right? And I did it using a nested for loop. I could have also done it using enumerate and iterating over the index of the inner loop. Like enumerate is pointless in this case. Let's just delete this and do this second thing, right? Iterating over the index in the inner loop. So let's say for index in range of len of inner list, that is in the first inner list there are 3 items, so range of len of inner list gives range of 3, so the item 0, 1, 2, sum of items plus equal to inner list of index. So I'm just accessing the same value. Instead of saying item, I'm saying inner list of index over here, and I'm appending it and I'll get the same answer. Cool. Moving on to the next one. So I have 2 sets in this dictionary, right? The first set has the key value SARC, and it has all the countries in the SARC block, right? And the second key value is BRICS, and it has all the countries in the BRICS group. So I'm just going to create this dictionary containing these 2 sets, right? And the value corresponding to SARC is a set of all the countries in SARC. So I'll say D equal to this value, right? Now print out all the values of the dictionary using nested loops. So I'm going to say for, so print out all the values using nested loops, right? So for val in d dot values, so that gives me each set, which is all these values. And then I want to like print out elements of that set, right? Item in val, let me just call it inner set, right? For item in inner set, print item, right? So I have an outer loop to access these sets one by one, and I have an inner loop to access the elements of the set one by one. Now if I run it, I get all these countries printed out one by one. And if I want to separate those outputs, I would say print set new set, right? So I would say new set with these values and then new set with these values. Let me remove this for now. Also find the union and intersection of the sets in this dictionary. So I've done the printing out. Now I have two sets, right? One set corresponds to the value sarc and one set corresponds to the value bricks. And so let me just like create these two sets over here. So I say set underscore one equal to D of sarc. So D of sarc is just the dictionary value corresponding to the key sarc. That's set one, right? Set 2 equals D of bricks. So let's just print set underscore 1, print set underscore 2. Let's see what we get. So set 1 has all these sarc countries and set 2 has all these bricks countries, right? In sets. Now I want to find the union and intersection of these sets. So let's say set print set underscore 1 dot union set underscore 2. That's what gives us the union. And if I say print set underscore 1 dot intersection set underscore 2, that gives us the intersection of the two sets. So the union is all these sets, all these values that are here. The intersection is only India. India is the only country that is present in both these sets. So that's what gives us only one value over here. So we've seen how to use nested for loops. The outer loop is used to access the individual sets, and the inner loop is used to access each value in the set. And in this case, over here, the outer set, the outer loop was to access each inner list, and the inner loop was to access each element in that inner list, right? So we've seen what nested for loops look like. So that brings us to the end of module 4, right? Congratulations, you've done a great job sticking up until this point. Let me just reiterate what we learned today, right? So we learned two main things under control structures. One is if, elif, else, that is if else conditions, right? So if a condition is true, do this, elif another condition true, do this, and finally you can have any number of elif conditions followed by else, which is like a catch-all where if all the other conditions are false, the else gets executed. You've also seen how to use nested if else conditions, right? Then we went to looping. Now, looping in Python is used to basically repeat a bunch of code a certain number of times, right? Like we saw first the while loop, and while loop is used when you want to execute a certain block of statements as long as a certain condition is true. And in the case of while loops, the first thing you do is initialize a variable outside the loop, then you use that variable in the condition of the while loop, and then you increment that variable or process that variable inside the block of code in the loop, right? Then we also saw certain loop control statements like break to break out of the entire loop. We saw continue to basically skip over the remaining statements in the loop and go back to the beginning to the next iteration. And then we saw the else keyword, which is used to basically have like certain exit conditions, right? Like you want to do some post processing once the loop executes, like you want to reset the value of a counter and so on. And then we saw for loops, right? And for loops are single, like the most important thing when it comes to looping. So for loops basically are used in two places, right? One is when you want to repeat a code n number of times, right? And that for that you would use the range function, and you know that range m comma n gives you values from m to n minus 1, like integers between m to n minus 1, with n excluded. And range of 10, for example, would give you 0 to 9. Okay, so we use the range function to run the for loop a fixed number of times. And if you want to iterate over all the elements in a collection, then you use a for loop. You say for item in collection, right? And then you process that item and do something with it. We also saw the case of nested for loops, where, for example, you can have a list of lists or a dictionary where the values are lists or another dictionary and so on. So you can have any number of levels of nesting, and at the innermost level, you will like access the element at the lowest list level or lowest level of data structure. So please practice, use all these exercises to better yourself, and see you on the other side with a new video very soon.